And then we've got a little bit of notes to do. We're not going to be in our normal notes packet today. We're obviously going to be on that cute handout. So we took a test yesterday on, it had polynomials, solving, graphing. It didn't have graphing, that's a lie. It had solving, long division, synthetic division. It had stuff about zeros, leading coefficient, degree, but it didn't actually have graphing. That's what we're going to handle the next couple days. And that will be on our next test. There are 2 sections on our next test. One of the 2 is graphing. Okay, so 5, you're still on my nerves. Let's discuss what's missing today. What's gone that's normally here. What's gone in the room that's normally here. Use your context clues.
Calculators.
5 and 3 get a point. The calculators are gone. There's a reason the calculators are gone. You're not in trouble for anything. You're not banned from them. But we actually don't need them for this section. This section is about knowing how to graph on our own without the calculators. So if you have your own graphing calculator like Arturo, I'm going to need you to put it away for this section. I'm even going to leave notes like if I see it out on the test, we're going to have a problem. So for this test only, it's more of a I can graph on my own, not with my graphing calculator. Okay, number 1, I need 2 things that multiply to 56. If you tell me 8 and 7, I'm going to be mad because neither of those are perfect squares. So what 2 numbers, one of them needs to be a perfect square. But if you tell me 8 and 7, I'm going to be mad. Neither of those are perfect squares. Something else. 4 and what? 4 and 14. So 2 and 3 get a point. 4 times 14 is 56. I know the square root of 4 is 2, so I have 2 square roots of 14. And now to deal with those variables. You can tell me what comes out, you can get a point. Say it again, Mackenzie. A and then what? And then what?
C squared. However, 1c will remain inside.
C to the what, Mackenzie? And then what else happens?
C will remain
Okay, Mackenzie started it off. I'm giving Mackenzie the point. So it's A, B squared, C squared, square root of 14C. Perfect. Number 2. 20. I'm needing to break it down. What times what is 20? I need one of those numbers to be a perfect square.
2 and 10.
2 and 10, neither of those are perfect squares. 4 and 5. If I do 4 and 5, I'm going to have 2 on the outside because square root of 4 is 2. 5 on the inside. Now I need help with the exponents. Anyone, not Arturo, he's got this. Probably not Mackenzie either. She's got this too. X, then what? I don't know, is it?
Because it's just X. Because then the X is fishing for the X.
Okay, you want to finish it, eh? And then tell me about what's underneath.
X.
And? Okay. Now, I knew there were going to be an X and a Y left in the radical because of Y. They didn't have a pair. Well, I mean, there were some pairs. There was an X that did not have a match, yes, but there's a more mathy way to say that. I knew from looking at this problem that there was going to be an X and a Y under the radical because they were odd exponents. Yes, because of the 3 and the 5. 3 get another point. So I knew there were going to not be any Z's left under the radical because it was Z to the 6. 6 is an even number. That's why I knew it was going to work out perfectly. 3 is a really easy one because of square root of 169. Yeah, you and her said it at the same time. So 3 and 6 get a point. We're supposed to know square root of 169 is 13. And then I would have m squared into the, and then I've left something off. What do I need to add?
And then remains inside.
An M underneath that radical. Thank you. Yes, you can. Okay, those are our 3 math workshop problems for today. Now, let's go to your cute little handout. Let's talk about it. Pay attention to how I fold it. It's okay if yours is not folded exactly. Literally, it's just to be cute. You do not have to be perfect. I'm going to fold the 2 left and right flaps inside. And then I'm going to fold the top and bottom flaps down. The only reason I'm folding it that way is that way it will say polynomial in behavior. I'm trying to be cute. I want to see the words. I did. I folded the left and right side and then the top and bottom because I wanted to see the words polynomial behavior. So fold the 2 white flaps over first, then the ones with the words. And again, just trying to be cute. So while you're doing that, let's talk about it. I actually jumped the gun because I didn't realize this past test did not have graphing. So we've actually talked about graphing, how to use that leading coefficient, how to use the zeros. We graphed 3 on our study guide the other day. So today should be no surprise. The only surprise is that until now I've let you use the calculator. And today I'm saying no longer. We're going to be able to do this with our brains. Okay, so today and tomorrow and Friday we're going to talk about graphing. We have a checkpoint on Friday, which means you got to get it together. We have a maze we're going to do today when we get this done. There are different parts of a graph. So you and I have been focusing on zeros, and we're actually going to focus on a different aspect of the graph today. So let's open it up. So we're back inside. And you still have your 4 loose graphs. We're going to talk about those 4 loose graphs now and try to match them with an equation. Okay, so things to know in life. What's another vocab term for highest power? What have we been calling it? The highest power. Yes, I don't get your point. We've been calling that degree. So if you want to add in the word degree, you sure can. Okay, so we've been dealing with highest power, and we've looked at degrees that are both even and odd. You can see on the screen, x to the 4. 4 is an even number, so that's an even degree. X to the 3rd, 3 is an odd number, so that's an odd. If the highest power is even, the graph looks a certain way. If the highest power is odd, a graph looks a certain other way. So we've got 4 graphs. 2 of them are evens, because 4 and 6 are even numbers. 2 of them are odds, because 3 and 3 odd numbers. And we're going to try to figure out which graph goes with which. So we're looking at our 4 graphs. Does anyone have a guess as to which graph should go with this first top picture? And again, we're not using our calculators even. No. Just a guess. It's not, it's one of the ones that looks like a W, yeah. It's going to be a W. And then if we're looking at our, so you're like, which one is it, Miss Compton? I just don't know. It sure would help if they had told us. You say, wait, which? Okay, it's supposed to be, which again, they could have labeled stuff better for us. It's supposed to be this one. Now let's talk about why and what we're supposed to learn today. Okay, so I'm actually not, we're going to tape them. I'm going to give you tape, and we're going to tape them at the end of class. For now, I want to actually see the graph and my equation at the same time. Okay, so you and I noticed the degree was 4. Lately, we've been making a list. What else have we been putting on our list? The leading coefficient. Tell me about that leading coefficient. Be very specific. It is 1, but it's... Give me a sign.
Oh, negative.
Is it positive or negative? It's positive. Thank you. Okay, so since our leading coefficient is positive, Since our leading coefficient is positive, that's going to change the look on our graph, whereas on the one below, that has a degree of 6, what's its leading coefficient? And that one's a little trickier. If you get that one, I'll give you a point. Negative what? No, ma'am.
3.
Yes, ma'am, you can have your point now. We would have to rewrite the equation to make it look a little more like the way you and I would want to see it. But we're smart. We could have done that in our head. Okay, so seriously, because, yes, both examples, let me zoom out. Both examples have positive degrees, but since they're leading coefficients, one is positive and one is negative, that's going to change the shape of our graph. So find the other W, and we're going to put it, and I'm going to place it facing down. So now let's look at our graphs. We have what looks like a W, and then what looks like a really messed up M. In fact, I'm going to color on my graphs. It's kind of hard to see. I don't know if y'all think it's hard to see or not, but I'm going to color on my graphs so I can see them a little more clearly. Okay, so lately you and I have been focused on, when we were talking about how to graph, we were focused on the zeros, which is where they cross the x-axis. And if we were to factor, we could probably figure all that out today. But we're not talking about those zeros today. We're actually wanting to talk about something else that leading coefficient and that degree are telling us. And the hint is to look at the little tiny pictures. We're wanting to look at end behavior. What do you think end behavior is? The direction on the end. I mean, it's what it implies. So the end behavior for this graph isn't this arrow going up and this arrow going up. So that's why they put up. And the direction on this graph isn't this arrow going down towards hell and this one going down towards hell. So that's why they put down. So we're looking at our end behavior. So if I were to give you a problem that was an x to the 4, like 2x to the 4th plus 3x squared plus 1, doesn't matter. Since it's a positive number in front, my end behavior is going to end up being both going up. So if it's an even, and it's a positive number in front, my end behavior is going to go up. Now, it might look like a normal W. That's not a normal W. It might look like a really stretched out W. There are a lot of ugly different ways it can make it look like a W. But regardless, on the ends, it's going to be going up if it's a positive number in front of an even exponent. Okay, and you're like, I wish my handout told me that. Sadly, it does. Your handout, if we're paying attention to our flaps, it tells you if the leading coefficient is bigger than 0, let me zoom out so you can see all the things. If the leading coefficient is bigger than 0, which basically means leading coefficient is positive, and we already talked about we're even, then my end behavior is up. If my leading coefficient is less than 0, aka a negative number, then my end behavior is going down. Both ends going down. Oh. And I think you already knew this anyway, because we've been dealing with, you forgot the word parabola the other day, but we've been dealing with parabolas for some time now. And if I had showed you the problem, like I want you to graph 2x squared plus 3, you would have told me it was a happy face. And if I had said graph negative 3x squared minus 1, you would have told me that was a sad face. And yeah, you and I learned it as happy and sad, but still the end behavior matches. It was an even degree, positive number in front, both ends went up. It was an even degree, negative number out front, so both ends went down. Are there any questions about that? Okay, so you know how you're just supposed to know that a parabola looks like a U, and we call it that this kind of an equation, you're supposed to know it's supposed to look like a U and an M? Sadly, you're supposed to know from now on that anything you see that's to the fourth, no matter what comes after it, if it's a positive one, it's going to look like a W. And if it's a negative one, it's going to look like an M. So from now on, if you see a W or an M, you're supposed to know that's degree 4. So on Arturo's next test, if he's given an equation that's a 4, and I don't see what looks like a W or what looks like an M on his paper, then he really didn't understand graphing. Because a 4 is always a W or an M. Now again, it doesn't have to be a pretty W, because Lord knows that is not a pretty M. That is a very, very ugly M. But still, regardless, if you had to name it as an alphabet letter, you would say, this is a W and this is an M. Okay, so we're cool with the evens. We need to have the exact same discussion, but with odds. So if we're looking at odds, we've got two different equations. One has that positive leading coefficient, and one has that negative leading coefficient. And seriously, that's also going to change our end behavior with odds. Now look at your two odd graphs. Why do odds stink? Look at them. What stinks about this? They do look the same, especially since they didn't tell us like where the top was and where the bottom was. They do look the same. That is really annoying. What else is terrible about the darn odds? In fact, I'll go ahead and put them in their right spots. And the only reason I know these are the right spots...
Miss Cox,
Yes, ma'am.
you have a long day back.
Yes, ma'am.
Please ask him to go to Coach Freeman's office.
Yes, ma'am.
Thank you.
Okay, the only reason I know these are the right spots is not because I've graphed it, but, you know, I understand in behavior 1, but 2 context clues. Notice that our other 2 graphs, they pointed out the end behavior in the bottom right corner, so I know it has to go like this. Okay, so we've got these 2 graphs. Let's not lie. I don't really know. I'm going to move these 2 because they're going to drive me crazy. I can't have all 4 and look at once. I just can't. ADHD kicks on it. Okay, so we have these 2 graphs. They both look, let's not lie, like weird ends. I don't know what letter you would classify them as. I always call them snakes. A cubic graph looks like a snake. So far we've learned today, Postman's running away. We've learned that if we see a x to the 4th, depending on whether it's positive or negative, if it's positive, we're thinking W. If it's a negative, we're thinking M. From today on, if we see a cubed, if it's positive, we're thinking of that snake crawling up the wall. And if it's negative, we're thinking of that snake crawling down the wall. And you're like, Miss Compton, how do you know if the snake's crawling up or down the wall? Look at that snake. I look at that bottom corner, or that corner, and I think about how that snake's going. I think in my mind, okay, snake's coming down, snake's going up. I don't know if that makes sense. That's just how I always viewed it. If you need to remember the N one is the normal one, and then backwards ends, I don't know. Cubics, they're not as easy as W's and M's. I'll give you that. Okay, so, but regardless, yes, we need to know that from now on, anything to the 3rd ends up making this kind of a shape. Maybe we were smart enough to realize that to begin with, because again, a cubic could cross the x-axis 1, 2, 3 times, and both of our graphs have 1, 2, 3 zeros, so maybe we were supposed to know that to begin with. But like I said, we're not even focusing on that, the zeros today. Oh no, we're looking at the end behavior. So what's really weird about cubics is that their end behaviors, or actually any odds, their end behaviors don't match. This one's going down, this one's going up. When we had ours to the 4th, they were both going up. Darn cubic, they're always doing the opposite. One's going down, one's going up. One's going up, one's going down. You actually have to pay attention. So there's a little more required from cubics, which stinks. So if it's an even exponent, our end behaviors match. They're both going the same direction. If it's an odd, they're going opposite directions, and it depends on if it's a positive or negative. If it's a positive, it always starts in the bottom left corner. And if it's a negative, it still always starts in the top left, which to me seems counterintuitive. You would think, if it's positive, why is it starting in the quadrant where both are negatives? But don't overthink your life. I swear, anytime it's positive, it starts down here. So when I hear cubic, the first thing I think to do is to start down here and make my snake. And if they put a negative number in front, I still have a snake, but sadly that snake's going the exact opposite way. So he used to start in quadrant 3, now he starts in quadrant 2. Okay, so I hope that kind of helps. I hope you kind of understood. We're still going to talk about, again, we got all this from degree and leading coefficient. We're still going to use zeros and multiplicity to help us figure out that junk in the middle. But that's what the next 2 days are for. I'm going to give you